Alright, welcome everyone to the next lesson in this series, and in this video we will look at load balancer type services and BGP advertisements. Now, in one of the previous lessons we looked at cluster IP services and how those services can be used by workloads inside the cluster to connect to services inside the cluster. Now, cluster IP services are not reachable by workloads outside the cluster, as in it's only routable within the cluster. When you want to expose a service so that workloads outside the cluster can connect to that service, we typically configure what is known as a load balancer type service and advertise the IP of that service to the external network so that you can steer inbound traffic towards the cluster. So in this lesson, we will leverage the BGP peering that we configured in the previous lab and configure a load balancer type service and look at how Calico assigns IP addresses to those type of services and how Calico can help advertise the CIDR range for load balancer services to the upstream network. So let's get started. Okay, so I've already gone ahead and deployed this lab. If you've cloned the repo, this lab can be found in the container lab calico-bgp-lb folder. And if you look at the topology, it's very similar to the topology of the previous BGP lab. We have a 3-node kind cluster, and we also use the ext-container to configure additional interfaces on these kind nodes. And we're also using the Arista CEOS image to simulate an external network. Let me show a diagram of what the lab topology looks like. Just ignore everything on the right here. We will cover this shortly. But this is what the lab topology looks like, and we've already configured the BGP peers from these nodes to the upstream router. Okay, so going back to the lab guide, let's export the kubeconfig, and the deploy script spits out the kubeconfig file. And once you've done so, you could do a kubectl get nodes to make sure you have access to the cluster. As you can see, this is a 3-node kind cluster. Okay. All right, now if I do a kubectl get pods, we see 2 Nginx deployments, right? And these 2 deployments, basically, if you look at the folders in this lab guide, we have a folder called tools. So if I do a cd tools, if I do a cat Nginx deployment, this is a very simple Nginx deployment. And along with the deployment, the script will also provision this particular service. So if I do a kubectl get services, since this is the default namespace, I could do a -n default as well. We see that the Nginx workload has a service named Nginx-service, and this service has a cluster IP. Now, with a cluster IP such as this service is accessible by workloads inside the cluster. However, if a workload outside the cluster wants to access this service, they will not be able to do so using the cluster IP. Now, one thing to bear in mind is with Calico's BGP peering, you can advertise the service side range to external networks, but this is typically not recommended in production environments. And one of the main reasons is the service side range tends to be the same for multiple Kubernetes clusters. So if you advertise these service siders for multiple clusters, you're going to have a routing conflict in your environment. So the service side range is only used internal to the cluster. And if you want a service to be accessible by workloads or clients outside the cluster, you configure a load balancer type service and allocate a routable, non-overlapping IP range for the load balancer service. Okay. Alrighty. So next, what we'll do is we'll make it so that this service is accessible by the external router here, by the CEOS image. All right. So what we're going to do first is we're going to define an IP pool. Now, remember, Calico already has an IP pool for a cluster. So if I do a kubectl get IP pools, this one is the default IP pool. And this IP pool, if you remember, is specified during install time. So if I look at my folder, there's a folder here called Calico CNI config. If I do a cd Calico CNI config, and if I look at the initial deployment manifest, we configure an IP pool, which basically has a CIDR range that corresponds with the cluster's pod CIDR range, and Calico allocates IP addresses to pods as they come up from this CIDR range. And we looked at this in detail during the pod networking lab. Okay. Now this IP pool that we're going to configure is different from the pod IP pool. If you look at the pod IP pool, the allowed users for this IP pool, so let me clear this and let me go back. So if I do a kubectl get IP pools, and if I do a kubectl get IP pools, let's specify the name here and do a -o YAML. Just give me a minute. That was a typo here. If I do a -o YAML there, this IP pool is usable for allocating IPs to workloads as well as IPs for tunnel interfaces. And we looked at how tunnel interfaces are configured in the VXLAN lab. Now, the IP pool we are going to configure is used for load balancer type services. Okay. So to apply this IP pool, you can do a kubectl apply. I have given the path to that manifest. All right. And we can see that the IP pool was created. So if I do a kubectl get IP pools, we now see 2 IP pools. And if I do a kubectl get IP pools, load balancer IP pool -o YAML, we see that this IP pool is now configured in the cluster. Now I have a CIDR range of 172.16.0.240/28. So what I'm essentially informing Calico to do is, when I create a load balancer type service, I'm informing Calico to assign an IP address to that service from this IP range. Okay. All right. So we looked at the IP pools, and next what we're going to do is create a load balancer type service for the Nginx workload. Okay, so we have an app equals Nginx, which matches the selectors, the labels in the Nginx workload. So this service will be backed by the Nginx pods. So to create this service, you can do a kubectl apply for this manifest. And once done, you can do a kubectl get services -n default. And we see a new service called lb-nginx-service created in the default namespace. This is a load balancer type service. And this service has a cluster IP as well. It has an internal IP as well. But in addition to the internal IP, it also has an external IP of 172.16.0.240. Okay. So this IP was assigned by Calico's IPAM controller for the load balancer service. Okay. So if I do a kubectl get endpoints for this service, we see 2 endpoints, and what you'll notice is that these 2 endpoints correspond with the IPs we have for the Nginx pod. So 137 and 67. Okay. All right, so with the load balancer type service created, next we need to advertise this to the upstream network so that clients outside the cluster or workloads outside the cluster can connect to this service. What we're going to do next is, now in this cluster, I already have the BGP peering with the CEOS image created. So if I go back to my diagram and let me expand on this a bit, this BGP peering is already up, and we did so in the previous lab. Okay. Now, when we configured the BGP peering, we configured a resource named BGP configuration. So if I do a kubectl get BGP configuration -o YAML, this resource basically specifies an autonomous system number for the cluster for Calico. And beyond that, we've not specified anything else in this resource. Now, if you want to advertise a particular CIDR range from the cluster to the upstream network, it needs to be configured in the BGP configuration resource. So we're going to make a modification. In this case, what we're saying here is advertise this CIDR range as a service load balancer IP, right? And this CIDR range is what we specified in the IP pool for load balancer services. So essentially what's going to happen is, whenever you create these services, it's going to receive an IP address from this range. From a BGP standpoint, we are advertising the entire range, the entire prefix, so that the upstream network will know how to forward the packets for any IP within that range. So to make the adjustment to the BGP configuration, you can copy and paste this command here. I have a manifest in the Calico CNI config folder with this new parameters configured. So if I look at the BGP configuration CRD now, we can see that we have the service load balancer IP parameter configured with the CIDR range that we want to advertise. Okay, so let me clear that output. And next, what we're going to do is we're going to verify routing from the CEOS container. So I'm going to exec into the container. So right now we are inside the router. And what we want to confirm is whether the prefixes are now available to the router. So if I do an enable and do a show IP route, we see a BGP route configured in the routing table. So this route basically says for 172.16.0240/28, forward the packet to 10.10.10.10. So if you look at 10.10.10.10, that is the IP address of the control plane node. Now, from a BGP standpoint, we're essentially advertising this prefix from all the three nodes. But this image, the CEOS image, is not configured for equal cost multipath routing. So it's going to pick one route. And as you can see, it's picked basically the first route advertised by the control plane node. Now, if you want the router to equally load balance inbound traffic to all the nodes in the cluster, you could configure equal cost multipath routing in the router, and then you will see multiple routes in the routing table. So let's go ahead and do that. So what I'm going to do next is, so also before that, to confirm that all the nodes are advertising the prefix, you could do a show IP BGP summary. And what this would essentially show you is that, all the nodes in the cluster are advertising a prefix. And also, if you do a show IP BGP, what you're going to see is that, we have that prefix, which is 172.16.0240 advertised by all our three nodes. However, only one is selected as the preferred route. Okay. So what we're going to do next is we're going to configure multipath. So I'm just going to do a config T, and let's do a router BGP 65001, which is the BGP instance of this router. And we're going to say maximum paths equal 4, which means the router will select up to 4 routes when those prefixes are advertised by downstream peers. So with that done, let me exit from this. And now if I do a show IP route, I'm going to see that for the prefix 172.16.0240, we now have 3 next hops, which corresponds with the 3 nodes in this cluster. Now, one thing to bear in mind is in this lab environment, I have peering from all the nodes. However, in production environments where you may have dozens, if not hundreds of nodes, you can be selective about the nodes that will peer with the upstream network, right? And those nodes can be dedicated to bring inbound traffic to the cluster. All right, and we'll explore that possibly in a separate future lesson. All right, so with the prefixes now available, what I can do is I can do a telnet to the IP address of the service. Now, one thing to bear in mind is the IP of the service could be different in your lab. If you looked at the output in this lab, so let me exit from here. Let me clear this. And if I do a kubectl get services, a typo there, if I do a kubectl get services, the IP of this lab was 172.16.0240, right? So if I go back to the CEOS image, and what I can do now is, given that we have the route available to us, we can try and telnet to that particular IP from the router. So if I do a telnet 172.16.0.240 in this case, right? Replace it with the IP you see in your lab. I'm going to say port 80. I was now able to successfully connect to the Nginx service. And for example, if I do get, we get a bad request from the Nginx pod. Okay. So what this essentially means is that this service is now accessible by clients or workloads outside the cluster. All right. So let's go back to this diagram to reiterate some of the points here. So what we did essentially was, and in this diagram, I have 10.16.0.241 as well. But in our lab, this IP turned out to be 240. So it may differ in your lab as well based on the number of load balancer type services you may have configured. But if you look at this diagram, what we essentially did was we created a load balancer type service as indicated by this service icon. And we advertise the LB pool CIDR prefix to the upstream router, right? And we looked at the routing table. We configured equal cost, multipath routing as well, so that the routing table sees multiple next hops for that particular IP address. And once it has its next hops, it can forward traffic to these cluster nodes, right? So as you try to connect to that IP, given that we're doing multipath, traffic may land on any of the three nodes. And one thing important to note is, once the traffic lands on a given node, the packet forwarding afterwards is very similar to how cluster IP forwarding happens in IP tables, right? In this video, I don't intend on doing a deep dive on IP tables and how those NAT rules are configured, but it is very similar. That packet is going to get destination natted to one of the IPs for the Nginx pod. And from that point onwards, it will follow typical and normal pod routing. And we've explored pod-to-pod routing as well as how cluster IP services are configured in detail. So please feel free to visit those lessons if you want to know how the underlying packet forwarding happens, once that packet reaches one of these nodes. And I'll probably, for load balancer type services, cover that in a future lesson as well. Okay. But for this lesson, what we've done is in this image here, we see all the manifests that were configured, or rather the custom resources that were configured. So the BGP configuration resource, we had a service load balancer IP that we are advertising. And we also configured an IP pool for load balancer type services. And in the router, we configured multipath so that it can forward traffic to multiple downstream peers or next hops. Okay. All right. So that's it for this lesson. I hope you enjoyed it. I will see you in the next one. Thanks for watching and bye for now.